We are live. Yes, we're super live and we are crisscrossing the globe. Super stoked to be doing, I believe, our first live stream with someone who's all the way on the other side of the world in Australia. Although originally not from Australia, James is the Thunder from down under. Our main man from Timescale is going to be doing a live stream with us today about OpenTelemetry, automatically instrumenting Kubernetes applications. We're going to get some good stuff in there. Before we get started, just want to drop the link for KubeCon. We were talking about KubeCon before we got started. And if you haven't signed up for KubeCon already, why not? You got the link right here in the YouTube. Super easy to sign up. It's free. Just add it to your Kubernetes registration. If you got any questions about that, get in touch. We've got over 30 talks, panels, live music. It's going to be amazing. If you're in Valencia, we will be having the coolest after party in human history on Monday at 5:30. James, very nice to have you with us today. What's up, man?
Not much. Just really the same as you, getting ready for KubeCon. I'm leaving next week to fly over there, which is amazing.
Yeah.
Packing. What a packing.
Packing, yeah, because you're, don't want to spoil too much, but you're also going on an extensive trip afterwards, correct?
Yeah, so pretty much I am spending 3 months in Europe afterwards, just catching up with people. I'm actually speaking at the Prague Postgres Developers Conference, just got confirmed. I've got a couple of CFPs out. So yeah, I'm keen to catch up with anyone that wants to talk to me about observability, databases, whatever. Hit me up on LinkedIn.
That sounds good. Now, you mentioned also before we got started that, live streams is something that you're getting into more and more. Can we just get a little bit of background about how you got into this space in the first place?
Yeah, so let's start with how I got into so I'm primarily a database person. So obviously I'm working for Timescale, it's a time series database company. So I sort of started out being a DBA and then worked for a company in Australia for a long time, 18 years, like pretty much unheard of, and got up to like the chief architect. And then from there, I was kind of thinking about where I could go. I mean, you can try and be the CTO for like a small company, or you can move to like a startup. And with the pandemic, it's kind of like opened up the world. Like all of a sudden, someone from Australia can work for like an American startup and they're totally into it. Big shout out to Timescale. It's amazing.
Yeah.
So yeah, moved into developer relations and it's been great so far. Been really enjoying it. It's really nice being part of a marketing organization rather than the sales one. Just the conversations are a lot more natural than I found I could get in my previous job. At least I knew someone really well.
That makes sense. And I can certainly say that from personal experience, from the people that I met from Timescale, starting out with Matt, REA, then moving on to Ryan, Lorraine, Carlota, everyone is, like you said, very, very down to earth and treating this in a serious way of putting people first. So I've got nothing but positive things to say about Timescale. Even got my Timescale swag right here too. But that being said, what are we going to be talking about today?
So we've been talking about OpenTelemetry and specifically OpenTelemetry in Kubernetes. So it's kind of like data from Kubernetes and then putting that back into K8s and storing it and persisting it. So we're probably going to be focusing more on the collection than we're on the persistence, but we'll talk about that as well.
Okay, sounds good. That being said, if you want to start sharing your screen, jump into your presentation, we can go for it. Folks, as usual, feel free to leave your questions here in YouTube. Also, James is very active on our Slack, so if you want to find him, he's quite easy to get there. Just be mindful of the time change, because right now where you are, you said it's 6 p.m. or it's 7 p.m.
6 p.m.
6 p.m. So yeah, so a solid time chunk away. But anyway, that being said, jump right in, go for it.
Cool. Can you see that come out?
Yeah, looks great.
Cool. So yeah, we're talking about automatically instrumenting Kubernetes applications with OpenTelemetry. So data that's produced by K8s and your applications in K8s, and then storing that in K8s. So it's like an inception kind of thing, I suppose. My name's James. I'm from Timescale. So we're going to run through what's observability. Just going to move this so I can see myself. There we go. OpenTelemetry and why you should care about it. And then we're going to talk about auto instrumentation. Then we're going to jump into the operator, so operating OpenTelemetry in Kubernetes. And then we're going to do a bit of a demo. So we're going to show exactly how easy it is. So I've got a Kubernetes demo that we're going to load up and then run the automatic instrumentation, and hopefully things will work. But let's see how we go. So why is that not working? There we go. A bit about me. As we said, I live in Sydney. My career has predominantly been around Postgres, a lot of Rust, a lot of Kubernetes, a lot of observability. I work at Timescale, which is a great company, and we are hiring at the moment. So head up our careers page if you're interested in jumping on board. You can find me on Twitter as James Sewell. You can find me on the Timescale Slack, the community Slack, and you can find me on LinkedIn as well. So what exactly is observability? So I'm kind of like going bottom up here in case there's some people that haven't come across this kind of stuff before, although I suspect most people have, and then we'll gradually work our way up. So observability, Wikipedia says it's a measure of how well internal states of a system can be inferred from knowledge of external outputs. That's pretty dry. So basically, the way that I see it is observability is a way that we can look into our applications and try and pull out information that gives us a way of describing how they're operating. So we're getting visibility into the health and performance of complex distributed applications. So we're basically talking about metrics, traces, and logs. So metrics are numeric data points at a point in time. So I'm using this much CPU, I'm using this much disk, this particular queue in my application has got this many items in it. Traces are just like timing throughout an application. So I'm entering this particular time, this particular application point, and then this particular operation is running for a certain amount of time. And if we nest a bunch of those together, then we get traces. So we've got nested traces, a parent trace, and then a whole bunch of child traces, and they describe a flow in our application. Then we've got logs. Everyone really knows what a log is by now. So it's basically just a textual representation of what's happening. So it could be an error message or whatever at a particular time. A lot of people talk about monitoring, and a lot of people talk about observability. Lots of people say monitoring is an old way of doing things, whereas observability is a new way. I mean, they're really just almost like different sides of the same coin, I think. So I think the main difference is that when you're talking about monitoring, you're really talking about things that you can confidently predict. So you can set an alert, or you can make a dashboard for something like, my disk's going to run out. I'm at 90% disk. That's a bad thing. I need to show a graph of that, and I want to alert when it gets there. Observability is more about not being able to predict future failure patterns. So just getting all the information you can to go and have a look at that after the fact and work out what's going on. So it's more about building insights rather than having predictions or knowing where things are going to go wrong. Basically, the rise in observability came about with the rise of complexity. So traditionally, we had these applications that had 2 to 5 components. And I know this is kind of like preaching to the choir here, but as we've moved into modern microservices, so with Kubernetes, we've got tens, thousands, even tens of thousands of components. Things scale up and down. We're deploying multiple times a day. We need to have some way to describe what's going on. So I need to know how my application flows through all those various points. And that's basically where OpenTelemetry comes in. So OpenTelemetry is basically a set of APIs and SDKs and also some tooling. This is the definition. We'll skip that and actually talk about what it actually means, I think. So it's an observability framework which focuses on collecting all of your signal types, so traces, metrics, and logs, and potentially transforming them and sending them onwards. It doesn't include a storage backend, and it doesn't include a query layer. It does include a collector, which is like a proxy that can also do some of those transformation operations. And this is kind of like a change in the way things are done. So if you look at that diagram down there, you can see that all of the other recent implementations that do observability data, so things like Loki, Prometheus, Jaeger, they all run across a single signal. So one does traces, one will do metrics, one will do logs. OpenTelemetry is saying, hey, why don't we just take everything that an application touches, so traces, metrics, and logs, and be really good at that, and then interface with anything we need to downstream. So we're not going to provide a way of storing the data. We're just going to provide a way of passing that data to whatever wants to store it. We're not going to provide a way of querying data because obviously that's the domain of the thing that's storing the data. So it's, in a way, it's taking the paradigm that's been used before and it's flipping on its head and saying we're going to do traces, we're going to do metrics, we're going to do logs, we're going to do them really well, and then we're going to offload, store, and query to things that are good at those. So basically, I suppose the question you ask is why, as a developer, probably do I need OpenTelemetry? So it's a single touch point for all your observability signals. It includes a collector, which can be deployed in many patterns. So I can send my metrics, my traces, my logs to this collector, and then it can operate on those. It can change the labeling on those. It can wrap those up. It can roll them up. It can send them off to another generator, another collector. It increases freedom, so you can use any storage you like. You can still take OpenTelemetry, then send your metrics to Prometheus. You can still take OpenTelemetry and send your traces to Jaeger. It plays with whatever you want to play, as long as those things support the OpenTelemetry protocol. And it defines semantic standards for use. So we'll talk about that a bit later on, but that's a pretty big one. So just a list of languages that it supports so far. So C++, Net, Erlang, and Elixir, Go, JavaScript, Node.js, PHP, Python, Ruby, Rust, and Swift. So it's a lot of the main languages out there people are using in Kubernetes land. There's new ones popping up occasionally. It's not a giant task to implement a new one. So I think as people decide they want a new language, it's quite possible that that will pop up in there. And the collector, so it's a standalone binary that's written in Go, and it receives, processes, and exports OpenTelemetry signals. So why would you need that? You can do all of the stuff the collector does in your application code, but you can also offload that. So I suppose this is really the way that microservices and Kubernetes like to work. So you could do everything in your application, but you want your application to be doing as little as possible. So you offload that into a collector. So your application doesn't have to know about routing. It doesn't have to know about how you're going to be aggregating up your metrics. You can do that somewhere else. So this is kind of like getting into the meat of the talk now. So order instrumentation, no longer about the dollars. So when you get down to it for traces, instrumentation looks something like this. So we've got a bunch of imports up the top here. This is Python. We've got some setup. So we're setting up our tracing objects. And then inside our application logic, we're saying we want to start a current trace or start a current span called server request. And then we're actually doing our application work down the bottom. And I suppose from the very start of doing things like this, so the very start of when tracing existed, people have been saying, hey, that's fine, but we've already got an application and we don't want our developers to go back and have to revisit every part of our application to re-instrument our code. So what if we had the ability to omit the tracing with no code changes or minimal code changes? And for a long time, that was like the feature that paid enterprise observability products pulled people in with. So people like, I think New Relic's got a really good implementation. Dynatrace does a lot of stuff like that. So basically you teach it about your application, and then it gathers the information it needs from your application by inspecting your application either at runtime or through injecting stuff into your application. So it's kind of like based on the premise that the people that make the observability framework have a good idea about the application frameworks. So the observability platform developers, in the old case, New Relic or whoever, need to go in and say, well, this is the kind of thing that you need to be looking at when you're doing an HTTP request, or this is the kind of information you'd want when you're doing a database call. And it also only makes sense where the framework's well known. Obviously, if it's a smaller framework, it's probably not going to get any love. And the language supports some way of injecting code. So there's some languages like Rust, which is one of my favorite languages, where this is probably not ever going to work in because it's compiled down to a static binary and you don't have any way of getting stuff in there. But for the languages where it does work, in a lot of cases, especially when you don't have a greenfields app or when you're moving something into Kubernetes, it's the holy grail. So you want to have a Python app, maybe it's running in Flask. You want to put that in Kubernetes and you want to be able to get traces out of it without having to go and do too much work. So for a long time, that's been something that people are really striving for. And it's something that OpenTelemetry supports out of the box. So as I said, it's only supported in some languages, not Rust. And it works kind of differently for different languages. So it's left as a language implementation. So the way it works in OpenTelemetry is people come along and they implement, or the OpenTelemetry project implements different languages and they implement the SDK for those languages. So for Python, you use a custom binary to run code, which injects OTel code. So rather than running Python or Flask to run your Python code, you run this OpenTelemetry shim, and that pushes data into your Python, imports what it needs, and then does the instrumentation. With Java, you run Java with Java agent, and you pass through the OTel stuff there. Ruby, you import a gem, and actually it looks like you have to perform some initial config. I'm not really a Ruby guy, but when I looked at that, that didn't look quite as automatically instrumented as some of the other stuff. And you can mix automatic with manual. So you can say, I want to have automatic instrumentation for my Python frameworks, but then I also want to go and manually implement some other stuff. So I suppose you have to remember what this is doing. So it's saying for the frameworks that I'm using within, say, Python, that OpenTelemetry knows about, I'm going to report data on those. So when I call the requests framework to go and get a web page, or when I make an HTTP call, or when I run a Flask web server and someone hits that, or when I make a call to Postgres, or when I make a call to Mongo, or something like that, all of that kind of stuff will be supported. But if you've got your own framework that you've written, that wouldn't be auto-instrumented out of the box. In that case, you need to go and manually instrument it. We'll have a bit of a look at that later when we do the demo. So one thing it doesn't do, which I was a bit confused about when I first ran it, so it doesn't instrument function calls. It's not a naive kind of thing. You can't expect it to go and tell you every time you call a function in Python. Obviously, if it did that, there'd be a lot of extra noise generated. And it doesn't instrument your application logic. So if you want to have particular tracing information about your application logic, then you'd need to go back and do that yourself. Having said that, it's a really good starting point. So a lot of the time, you could probably just have auto instrumentation. All of the time, auto instrumentation is going to be better than having nothing. And it's also got this thing called semantic conventions. So I suppose it's the idea that we're going to have a list of conventions to ensure that similar libraries, even between languages, instrument tracing in the same way. So basically, users who are looking at the telemetry data, so someone that's sitting in front of Grafana looking at tracing information, they don't have to say, I know that this trace comes from this particular library in Python. It's going to have these particular features that are specific. They'll be able to look at that, and it should look fairly similar to a request that's coming from another language using the same kind of framework. Obviously, these are semantic conventions, so it's completely up to the people that implement the framework auto instrumentation to obey them. But I suppose there's at least a set of guidelines there to help people do the right thing. So at the moment, there's a bunch of general conventions, HTTP, so for HTTP clients and server spans, databases for NoSQL and SQL databases, RPC for remote procedure calls, messaging, and a bunch of other ones, you can read them. So I suppose that list gives you an idea of the kinds of things you can get automatic instrumentation for in OpenTelemetry. So here's a shameless plug alert. There's an article I did when I first started with Timescale, actually, which was not so long ago, 2 months ago. That's a guide on, from nothing, creating a demo Python app and tracing it manually and tracing it automatically. So what we're doing is going to be a bit different. We're going to be looking at how to do it in Kubernetes when we get there. But if you want a sort of basic guide to how to do that in Python, then you can have a look at that article. So now we've kind of talked about OpenTelemetry, what it does, specifically looking at traces. And now we're going to be talking about how to actually operate it. So this is the operating in K8's bit. So the pattern kind of looks like this. So we've got an OpenTelemetry operator, which is this green, is that a hexagon? Hexagon here. It's responsible for observing two CIDs, so custom resources. So there's a collector and an instrument CID. And then based on the collector CID, it does these orange bits here. So it can deploy a collector as a standalone deployment. It can deploy a collector as a daemon set, and it can also inject a collector as a sidecar into an application container. We'll have a bit more of a talk about why you might use each of those patterns in a second, but it can also do instrumentation. So it can automatically create a sidecar container based on the instrument CRD, which will inject everything you need to auto instrument your code into your application container or as an init container. So we take Python as an example. You have your configuration and instrument CRD. Your application container starts up. You've got an annotation on your application container. The OTel operator says that's starting. It uses a mutating webhook, ejects your init container into the application container. The init container runs. It copies in all of the Python libraries that you need for auto instrumentation. It changes the runtime components, so it changes the Python command line that application container is using, and then the application container starts up and it's magically got all of your auto instrumentation. So the two CRDs, so there's the OpenTelemetry collectors CRD, so that deploys and manages collector pods. So if you remember, collectors were basically the routing and aggregation logic that we use. So that can be a deployment if you just want a single deployment or multiple nodes in a deployment. A daemon set if we want to run one of them specifically on each node we've got, and it can be a sidecar container as we just mentioned. So that uses an annotation on the pods to locate the pod, and then it injects in the sidecar container. So I suppose it really depends on what you want to do. So most of the time, you'd probably use the default, which is a deployment. Some of the time you might say, well, actually my nodes, I want to have one of these per node, so I'm going to have something on every node. I want to specifically bind it. I don't want the traffic for my observability leaving the nodes. I might have a daemon set, then I just route to the local node. And sometimes you might say this specific application needs to have its own collection logic. Maybe I'm doing a bunch of specific aggregation only for that one. Maybe I'm going to put that right in there, put it right next to it as a sidecar. When you're doing the CRD, you supply the config for the operator. At the moment, it's a non-typed text blob. So you've just got a blob of text that gets converted into the config, copied into your collector. Hopefully that's going to change in the future. I need to, one of the maintainers for this works at Timescale, so I'm going to have a chat to him and see if we can get that changed, because that doesn't play particularly nicely with stuff like customize. And you can have as many collectors as you want. So you just create one CRD instance per collector and it'll start it up. We'll have a look at how this works later. Then we've got the instrumentation CRD. So we can do auto instrumentation at the moment for Python, Node.js, and Java. You can do auto instrumentation for a few more languages as part of OpenTelemetry, but it's just those three that are supported as part of the operator. Interestingly, you can only do Node.js, you can't do JavaScript or any other JavaScript-based language, I think. But I'm sure you can probably make it work. Once again, it uses an annotation to locate pods. You've got to put the annotation on the pod, not the deployment, which is a bit confusing. And then it uses a mutating webhook to attach the init container. The init container runs, as I said, and does all the good stuff in there. The config includes which collector to route stuff to, so you can have a different collector for every different language if you wanted to. Obviously, you have to make sure you restart your pods if the pods have already started. Otherwise, they won't get the init container and they won't have the telemetry info coming out. So you can find that project on GitHub and the OpenTelemetry repo, OpenTelemetry Operator, and you can install it with a kubectl, just pointing at the latest release. We'll give that a go in a second. So that's kind of like the nuts and bolts. So basically we have observability. OpenTelemetry is taking observability and providing a way to combine metrics, logs, and traces into the same framework. So we only need to use one framework when we're developing our code. The OpenTelemetry operator is then providing a way to use that in Kubernetes as easily as possible with automatic instrumentation when we can. So looking back, here's a previous DoK talk, which was done by one of my colleagues who I haven't actually met yet, but I will meet at KubeCon, John Pruitt. So he was talking about what more can I learn from OpenTelemetry traces. So his thing was basically taking the stuff that I was just talking about But he's coming up from the angle of I've got the data and I want to learn from the data. So he's got the trace data, it's coming through OpenTelemetry, he's putting it through PromScale, which we're going to look in a second, and then he's analyzing it with SQL. The reason I put this up is we're going to take his demo application and we're going to change it for our purposes. But that's a great talk as well. So I've got the link down there. If you want to have a look, then it's definitely worth a watch. So his test application, it's basically a really, really over-architected password generator. You run it from Docker Compose. It's in the Timescale GitHub /OpenTelemetry demo. And it's got a bunch of dashboards in Grafana that come up and it shows the trace information. So the whole point of his talk was you could query that information. You could make some really cool dashboards using SQL. And actually another plug alert is there's actually a CNCF article coming out as part of KubeCon about why we at Timescale think that SQL is the best choice for OpenTelemetry. I won't talk about that too much now, but if anyone wants to talk about that, I'm really keen to have some discussions around that. And you can learn a bit more about the test application as well. There's a blog post. So the blog post was like a companion blog post for the video that I showed just before.
I guess what would be the, if I may, what would be the second best choice apart from SQL for OpenTelemetry?
Yeah, so at the moment, the landscape's a bit strange. So OpenTelemetry doesn't specify a query language. It says install the data in whatever you want. So at the moment, what most people would be doing is they'd be storing their metric data in Prometheus, then they're using PromQL. PromQL obviously can't talk to the trace data and it can't talk to the log data. So it's like what we've done is we've flipped things on their end with OpenTelemetry. We're now saying this on the left-hand side of our diagram is going to include metrics, logs, and traces. But on the other side, our query doesn't have those three components. I think there's a few forays or some gentle pushes coming to have like a query language that supports all three types. But my argument would be that if you take three generalist languages and try and turn them into one sort of superset language, we're getting closer and closer towards what SQL is anyway. So SQL is a language that's thought of about data analytics. It's known by many, many people. It's supported by many, many applications. If you watch John's talk, you'll see you can do some really cool stuff with it, with traces that you can't do with some of the other tracing stuff on the market. So why do we need to reinvent the wheel when we've got this language here, which is really good? I mean, I love PromQL, but the really good thing about PromQL is the simplicity. So you can write things which might take a bit more, might be a bit verbose in SQL and PromQL. But if you try to bolt a million other bits onto PromQL, you then lose the very simplicity that makes it a good thing to start with. So I suppose this is like a weird kind of time. Like OpenTelemetry's come along, it's super popular. It's actually the second most popular by commits and contributors CNCF project at the moment. So it's actually eclipsing everything apart from Kubernetes itself. And it's come in, it's changed the way that people think about this, but there needs to be an answer on the query side as well. That's kind of what the article's about.
Okay, good. That's, I mean, well, obviously we don't want to spoil the article, but I think knowing, that just seeing like the rise of OpenTelemetry, getting to that second position because all the focus goes to Kubernetes, but being second to Kubernetes is no small feat. What do you think is about it that people are finding so engaging that's getting that kind of traction?
Yes, I think there's two things. I think initially the reason that it took off so quickly is because a lot of vendors got involved, and a lot of people would think vendors getting involved is not necessarily a good thing, but then I would argue that's actually a great thing. So if people like VMware, if people like I think AWS, if people like Microsoft are using it, if people like New Relic are using it, if people like Splunk are using it, they're not just using it because it's a fad.
Yeah,
it's quite uncommon for this many companies to all of a sudden take up something like this and run with it. And the reason they're doing that is because it means that you can take a lot of sort of separated systems that don't know anything about each other. For them, they don't really mind about the query or the storage, but for them, they can take data from all of these feeds and they can expect it to be sort of semantically equivalent. So they can analyze it in the same way. So it's great for that kind of thing. So I think that's what kicked it off. A lot of big players coming in. Yeah. And then I think the community has been growing really fast. So there's a lot of people that are now jumping in. It's quite a welcoming community, although sometimes the concepts can be a bit complicated. So that's one of the things we're kind of hoping to help out with, sort of having a lot more articles based on like, this is how you actually use this stuff. There's actually a working group, I think, starting off to have a bit of a better demo suite across the whole platform. But yeah, I think that those are the two things. So the community is growing really quickly, and it was initially bootstrapped by a lot of large companies that are dog fooding it. They're using it internally, so they're pushing stuff in.
Yep, good. All right. Anyway, we'll definitely be keeping our eyes open for that article. But yeah, crack on.
Yeah. Cool. Okay. So this is how the sort of demo application works. So we've got a load service that's just making HTTP requests to a generator service. This is all in Docker Compose with this version of the diagram. Then the generator service makes a lot of calls to upper, special, lower, and digit. So it's saying, I need to make a password. I'm going to get one uppercase letter, and then the uppercase letter actually passes it back a number of uppercase letters. It gets a really long string, then it randomizes it and prunes it back to the amount of characters it needs and gives it back. So it's pretty much worst case scenario for if you want to generate a password with microservices, but it displays what we need to do here really well because you get a lot of deeply nested traces. All of that data is then sent to the OpenTelemetry collector, and then the OpenTelemetry collector sends that to PromScale, which in our case is sending that into TimescaleDB. So the stuff in that box is the storage layer, and obviously that's not part of OpenTelemetry, but that's what we've chosen to use for John's talk at least. Well, for this one as well. So note on persistence. So we know that OpenTelemetry can send data to any backend or any backend that supports OpenTelemetry. So it can send traces to Jaeger. It can send Prometheus data to Prometheus. So what did we choose for this demo? We obviously at Timescale chose our product, which is called PromScale. So it's a stateless app that takes inputs from OpenTelemetry and also from some other things like Prometheus and stores them in a TimescaleDB enhanced Postgres instance. So traces are about to go live, or GA, I think, as part of KubeCon. They're under a feature flag at the moment, so we're using that feature flag, but that's been around for a while. We only support Prometheus metrics at the moment, and logs are coming later on. But the general idea is once all of these bits and pieces come live, you're going to be able to use SQL to query across them. So we're saying we want to have a common query language for all of your OpenTelemetry data in the same way that we've now got a common creation language for all of our OpenTelemetry data. Cool. So as part of what I did for this talk, I made some changes to the app. So I busted it out of Docker Compose and put it into customized YAML that we could run in Kubernetes. I removed all of mention. So I went through and removed every OpenTelemetry import, every OpenTelemetry piece of code, every OpenTelemetry Python requirement, so that it's just the microservices with nothing in them. We'll have a look at that in a second. And then I changed the lower service from Ruby to Python. So I needed to do that because Ruby's not supported for automatic instrumentation, and Python is. So I thought we'll just go with Python across the stack. I could have moved it from Ruby to Java, but I'm not a Java developer, so I didn't have the week that would take me to get my head around doing it in Java. I added in a new feature. So every time a password is created, it's saved to and checked against the Postgres database. So you make your password, it gets all the characters from the various services. Then right at the end, when we get back to the generator and it finally says I've got enough inputs, it talks to Postgres, puts a hash digest of that into the database. And if it's been used before, that will hit the primary key on that table and it will fail. So it's basically a way of putting in a feature that has a database call. So that's what I want to do, have a database call that lets us make sure that passwords aren't used twice. But of course, passwords would never be used twice in this case because it's the password generator app. So I also added an anti-feature where 1 in every 100 times it'll work out this complex password, then it'll just biff that out and use password 123 and then fail the Postgres check. So I suppose the main thing here is I've taken out all of the OpenTelemetry imports, code requirements, and I've moved from Docker Compose to K8s, so we can run it in Kubernetes. And from then on, it's all downhill. So basically what we're going to go through is we're going to load up Kubernetes. I've just got an EKS cluster that's running. We're going to add in the OpenTelemetry operator. We're going to add in a collector CRD. We're going to add in an instrument CRD. We're going to annotate our pods. Well, the pods are actually already annotated. We're going to create our pods. And then we don't actually need to restart our deployments because we're going to be creating our pods at the end. So let's jump into it. So if we just, can you see that? Is that showing my browser now?
Yep.
Yeah, so here's the OpenTelemetry demo, Timescale/OpenTelemetry demo on GitHub. I'm in the K8 branch, which is what I've pushed my changes to. They'll eventually be merged back into the main branch, but for now they're just living in the K8 branch. So if we come down here, we've got a running the system in Kubernetes section. So in order to run the OpenTelemetry operator, you've got to install Cert Manager. I've already done that in my cluster. So we're just going to grab this command here, which is running the OpenTelemetry operator. Then we're going to jump into a terminal. Here. And we're going to paste that. That's going to go and download the OpenTelemetry operator from GitHub and apply it into our running cluster. It's a little bit slow because the EKS cluster is in America, yet I'm in Sydney, but it'll get there in the end. So basically this is getting all the bits and pieces. So it's making sure that all of the CRDs are available. It's making sure the mutating webhook's going to work, making sure all the services and controls needed for all the bits and pieces are there. Cool. So if we now do kubectl get CRDs, grep for open, we can see we've got instrumentations and collectors. And in fact, if I do kubectl get spaces, I can't remember what it's called. Okay, we've now got an OpenTelemetry operator system namespaces, and if we do get pods, actually we'll just do have a look in there. We can see we've got our operator controller in there. It's up and it's running. So basically now we've got a cluster that has the OpenTelemetry operator running in it, and we're ready to start creating pods. So if we quickly just have a look at what we've got in here, if we jump into the, let's have a look at the instrumented code. So this is the original code that John created. If we have a look at the generator function, you can see up the top here, we've got a whole bunch of OpenTelemetry imports. So we've got, I don't know, maybe 10 lines of imports there. Then we've got some configuration here. So we're configuring a tracer provider, and then we're getting our tracer going. Then within our functions, we've got a whole bunch of tracing start points. So we're saying with a tracer, do this stuff. So start a trace here, and the trace will finish when this block finishes, then send that data to PromScale through OpenTelemetry. If we then go back out and come to the new directory, so I've taken all of that out. So there's no mention of OpenTelemetry in here. There's no OpenTelemetry imports. It's just the raw functions doing what they need to do. If we jump into the YAML directory, then there's a whole bunch of YAML here. So if we have a look at app, here are all our services. So we've got check, digit, generator, load, lower, special, and upper. If we have a look at what the deployment of one of them, you can see it's just a pretty standard deployment. I've got 3 replicas for everything because why not? And we've got this annotation here. So it's an annotation inside the template for the deployment. So this will end up on the pod. And we're saying instrumentation.opentelemetry.io/inject Python is true. So for this particular app, we're going to inject a Python init container, which is then going to turn OpenTelemetry on. So if we have a look at the pods that are running, I don't think there should be anything. Nothing found in that namespace. And then if we do kubectl apply -k dot, it's then going to start up all of our stuff eventually. So this is going to do not only your application, it's also going to set up Grafana, it's going to set up Jaeger, it's going to set up PromScale, and it's going to set up Timescale, and it's going to link them all together. So the OpenTelemetry information will be coming out of our app. It'll be going into PromScale and then into Timescale. Then we can visualize that through Grafana, and actually it's going into Jaeger as well. Cool. So one thing I forgot to actually look at before we did that, but we can have a look at it now, is we've got this OpenTelemetry CRDs directory. So in here, we've got a collector and an instrumentation CRD instance. So in the collector one, it's pretty simple. We're just giving it a name, then we're just giving it the config, and the config is just a big blob of text. So in this case, we're saying that we want to receive OpenTelemetry protocol data via HTTP. We want to batch that up with a processor. So all of this is documented on the website. And then we want to export it to PromScale. So we're sending to our OpenTelemetry protocol endpoint, and we're going to send it to PromScale. In this case, it's insecure because I haven't set up certificates for it, and we're not using compression. And then down here, we're saying our pipelines for traces. So we're going to send it to OLTP. We're going to process it, and we're going to export it. So basically what that's done is that started up somewhere around here. This demo collector here. So the demo collector has been started up by the operator using that configuration in the CRD. And then when we look at the instrumentation one, we're saying we want to have automatic instrumentation, and we want to send automatic instrumentation to our demo collector, which we just started up. And we want to be sending trace context and baggage. So we're sending trace information, and baggage is like a way of defining things that are included in trace context, which we're not actually using here. So you can see that all of my containers here, or sorry, all of my pods have one of one ready. That's because they actually started before the CRDs were created. But if I was to restart deployment check, then we wait for that to restart. You see that it's now running an init container, and now it's starting up. So if we just do each of these, because I did it in the wrong order, so if we do load, color, upper, special. So this is just restarting these deployments. It's just stopping the pods and starting them. So I'm not sure which ones of them actually started before we did that. That's all of them. Now we just wait for that to stabilize. Actually, while we're waiting for it to stabilize, we can come over here and we can run this port forward script. So if you have a look back at the instructions, it's got instructions for running the port forwarding. So that's going to start up the port forwards in the same way that the Docker one does. So it'll make sure that everything's running on the same port forwarding as happened with the Docker one, which you can see up there. So we're going to run port forward. That's going to start our port forwards. And then we should be able to do curl localhost 5000, which is the generator service, and we should get back a password after a while. It's quite slow because there's a whole bunch of things that slow it down, because obviously we want to see it being slow in the traces, because we want to be able to use the traces to try and work out what's going on. So we've got back a password there, which is great. If we now jump back into Grafana, Grafana for the first time, I should say. So that's been port forwarded to localhost 3000. Log in as admin. It's going to make us change the password, so we'll just change it to the same as it was before. Cool. So this is information that's being created automatically from the traces that are passed through into Timescale. These are John's dashboards, so it's querying that information by SQL from the Timescale database. But you can see that from that, it's already worked out what the dependency tree for our application is. So requests are being created by load, they're coming to generator, then generator's running check, lower, digit, special, and upper. If we come back here and go into request durations, there we can already see information on the request durations. If these dashboards look interesting to you, then I'd really suggest that you go and watch John's talk, because it's really great. What we're going to do for our purposes is we're going to click on the slowest trace ID. It's going to show us the trace. And as you can see, it's doing a lot of calls. And some of those calls have been artificially slowed down by the application code. But we can click on any one of them and see what's going on. So for this HTTP GET from, actually, let's choose one of the other ones. Let's have a look at a digit call. So for this digit call, we can see that it's HTTP 1.1. It's to the digit host. It came back with a status code of 200. We can see what the port is. We can see who was calling it. And we can see that this information is coming from Flask. So it's auto instrumentation information coming from Python Flask. Then we can also see the Kubernetes stuff. So the operators added in the Kubernetes information. So this is coming from a particular node. It's coming from a particular pod. And then we can see what the deployment name is. So basically, we can use this to trace exactly what's going on with it zero. We could have just dropped in any application that was using the frameworks which are allowed to be used. So anything that uses Python Flask requests, a large number of database products, a lot of caching products. And if we go right down the bottom, we're going to see we've got our check. And in this particular case, it's looking like the check got an error. So it's obviously one of the ones where we've hit our password that's been changed to password 123. Oh, no, so that's saying it can't connect to the server TimescaleDB. So obviously the server hadn't come up when this was running. But regardless of that, I think, okay, so that's probably not a good example. That one happened slightly too soon before the TimescaleDB process came up. But if we find another trace ID, so we search by things that include check. Again, maybe we do HTTP dot. Actually, that'll probably do. Choose another one of these. It's actually worked. So this is kind of just showing the information that we can get out for a Postgres call. So we can see that the Postgres call was an insert. And we can see the Postgres statement in here as well. So then again, this is with zero work on our part. This is just something that's been captured and been defined by the OpenTelemetry team for automatic instrumentation. So we can see insert into used passwords, values S. We haven't got the value there because of how we wrote the query. We can see that the database system was Postgres, the user was Postgres, peer name was TimescaleDB. So it's a lot of information that we can get out practically for free. So I suppose the main takeaway here is if you've got an app that's in Python or Java or Node.js, and it's running in Kubernetes and you don't have any tracing information available today, and you're using standard libraries, which I'm sure most people do in microservices these days, then you can use the OpenTelemetry operator to very quickly get trace information about what's happening in your application. And if you want to persist that information in Timescale, then you can query it via SQL and get some pretty cool dashboards pretty quickly. You can also send the information into Jaeger if that's the way that you do things. You can also put it into anything else that supports OpenTelemetry. So you could perhaps send it to Datadog or New Relic or something like that. We flip back to the slides. It's about the end of the demo. So that's it. Thank you. The Timescale community, if anyone's interested in talking about this more. So we've got a Slack forum, a Slack instance, and we've also got a forum if you want to do some more, I suppose, asynchronous stuff. The forum's good for searching for previous questions. Slack can also be a bit weird for that, but if you want to ask some questions and get some answers straight away, then Slack's a good place to do that.
Very, very good. Awesome. Can you stop sharing your screen real quick, just as we're getting towards the end?
Yep, okay.
All righty. Cool, cool, cool.
Here we go.
Good. Just a couple of things before we wrap up is, you had mentioned earlier, all right, so we've got OpenTelemetry second after Kubernetes, but despite the amount of interest that's going in there, what's preventing OpenTelemetry from going further? Not necessarily overtaking Kubernetes, but what are some of the things you think that people typically find difficult about getting in? Are there barriers? Are there blockers? Do you have to unlearn things to be able to understand it better? What kind of things do you think would make it more comfortable?
Yeah, so I think one of the initial things, so I started learning about OpenTelemetry in the last 2 months. So I'm pretty much was at that stage.
But that's good. Ago. I mean, you can really understand that from a firsthand experience.
Yeah, absolutely. So I think at the start when someone comes to it, you're really excited about the promise of it doing all of your 3 signal types in one SDK, one language, one API. I think one of the problems that OpenTelemetry has is when you look at the OpenTelemetry website, it can be quite technical. So OpenTelemetry is a system that's been designed to interface with a lot of other systems. So it can take Prometheus data, it can take OpenCensus data, it can take OpenTracing data, and it can present those in a standard way as well. And I think one of the things that means is it's quite a complex system under the hood when you compare it to something like Prometheus. So making sure that you've got your mental model correct about how it works can take quite a while. And that's something that I'm hoping to do some work on, put out some blog posts that sort of say, you don't need to know all the technical details, but as a developer, this is what you need to understand to use it. You don't necessarily, to start with, care about the nuts and bolts. You just want to know how to make it work and make sure that you're doing that in as best way you can.
That's good. And that's something that I don't think, that's something I don't think is unique to OpenTelemetry or Kubernetes. It's the overwhelming, I've got to learn absolutely everything. And like you said, maybe at a functional level, that's simply not necessary. And that way you can focus on the things that are going to provide direct value.
Yeah, and I mean, Kubernetes is exactly the same, right? Like if you want to understand everything about how Kubernetes works in your first month of using Kubernetes, that's just not going to happen. Yeah. Like you really need to take an approach that shows you how to use the stuff that you need to know and then keep on building on it and building on it and building on it. And I think it's the same. It's unfortunate though that, especially for OpenTelemetry, the docs can be quite complex. But we're hoping to help out there.
Yeah, that's why we have community. That's okay. And like you said, a little bit of patience goes a long way for when it comes to learning and adopting these new technologies. Another thing is that, so when you have a very strong database background, and we're looking at these things, we're talking about observability, tracing, logging, et cetera. These are conversations we've had with other people in the SRE space, like Alex Jones, and also a wonderful SRE from Google. I can't remember his surname. His first name's Yuri. Shout out to Yuri. But seeing the sort of, and we had a talk from Patrick McFadden from DataStax about the road from DBA to SRE. And so we see these sort of these blending principles and roles that are evolving. Do you think that people that are in the database space should be opening up more to these kinds of concepts?
Yeah, absolutely. I mean, I suppose it's a bit of a strange one because DBA at this stage feels almost like an antiquated job title. I would argue that
no offense to any of the DBAs out there, but
no offense to DBAs, but anyone that is a DBA, is an effective DBA, is already operating with many hats and is probably doing the equivalent to what someone doing SRE stuff would do. I mean, they're a bit more niche, but it's funny, like when I went to university, the database papers were really strong and people wanted to be a DBA. I don't think that happens anymore. Like my previous company, we tried to hire DBAs and you struggle to find people. Everyone wants to be playing with the new hotness, but I think the skills are like transferable. Like I think in the technical world, it's often knowing how to talk about things, how to communicate things with people, and knowing how to approach problems rather than actually being a niche player of one particular. part of the world.
Got that. And like you said, in terms of the approach, and the one particular live stream that we had with this one from Google was, talking about a lot of this is customer facing. You've got to be translating technical stuff into non-technical language, getting rid of jargon, things like that. When we talk about SLOs, SLIs, et cetera, you're very much in a business-based scenario where someone is paid for a certain amount of service. They have to understand that there's going to be downtimes, that there's going to be moments where that's not going to happen. It's just what are the percentages on that in terms of what's in your SLA, and then based on that, how do you develop your SLIs, SLOs, et cetera. So I think that it's interesting to see how this is building out. Would you? I like where I guess is that tomato is one an SRE or a DBRE, and like you said, wearing different hats. And looking at the perspective of stakeholders, when we're talking about organizations that want to be running data on Kubernetes, it's not that there's a magic number of saying, well, how many DBREs do you have? I don't think it's really so much about that as, what are the technologies they've been working with and where do their strengths lie? I don't know. What do you think about that?
Yeah, I mean, I don't think there's ever going to be a magic number of like the amount of people you've got doing something. And as soon as you start running on data on Kubernetes, that's an interesting intersection because you can have as many people that are database specific as you want, but you need to then have people that are Kubernetes specific as well, or you need to have a team of all-rounders, because I suppose one of the things about running data on Kubernetes is you need to acknowledge that you need to be good at Kubernetes, or you need to pay someone like Amazon that's good at Kubernetes for you.
And don't pay Amazon. but yeah, I know what you mean. That level of expertise. And this actually gets to a question that we ask all of our speakers. So I'd like to know your take on this. Is because we're talking about the things that need to happen to make OpenTelemetry easier and to sort of unblock the pathways. And you mentioned some things about docs. And once again, great. I cannot speak highly enough of the community folks that I met in Timescale. Massive shout out to Lorraine, as well as Ryan and Carlota. And anyway, so I think that's a strong point. But the question that we ask, our sort of $1 million question that we ask all of our speakers, is what, in your opinion, what do you feel is the major challenge for more organizations to run data on Kubernetes, stateful workloads? Is it a talent issue of not having the right people? So like you said, then you have to depend on Amazon. Is it a financial issue? It's a technical issue. What do you think is the primary thing that's getting in the way for more organizations to do this?
Yeah, I mean, I think at a technical level, the main issue is that when people were running large databases on-prem and on servers, they'd been doing that, or companies have been doing that for a long time. So there's a lot of base knowledge about what you need to do when you do that. And I suppose Kubernetes is quite a new thing. So it's translating that kind of knowledge into the Kubernetes world. So you can say stuff like, I know that this database may have an outage at some stage, but I need to be able to go on and know how to fix it. So previously companies used people like VMware to come up with a file system, and people knew how to interact with VMware. It's translating that knowledge into the Kubernetes world. So I don't think running data on Kubernetes to me doesn't seem like a scary thing at all, as long as your company knows how to use Kubernetes, right? Before, running data on Linux seemed like a scary thing to people when Unix was the mainstay and people weren't used to Linux. So it's just making sure that you're comfortable with the thing that you've got your mission critical data on. If you can get to that point, then I think you can acknowledge that, we can use Kubernetes for this because we're happy with Kubernetes. When something goes wrong with Kubernetes, we know how to fix Kubernetes. If you're just throwing stuff into something, you don't know how it works, that's when you get into trouble, I think.
Very, very good answer. And so extracting from that, it's a question of confidence, comfort zone, experience, having the proper amount of contact with those technologies. That's great. Very good answer, James. Nice. That being said, we are almost at the end. You're pretty easy to find. You shared your links previously for LinkedIn, Twitter, etc. While you've been speaking, we have an amazing artist who's in the background, lurking in the shadows. His name is Angel. And so he created this artistic representation of the various topics that you touched on. Obviously, we would need about 10 drawings to get all of them in there. But I think it's nice. And observability with the astronomy theme. And we've even got a UFO flying out there. That's kind of cool. James, it was great to have you on with us. We very much hope to get something going on the ground in Sydney at some point when you come back from your lovely trip in Europe. But very active community member. This is what we're looking for, folks. People like James. So if you want to get in touch with him, just reach out in Slack. And remember, if you haven't signed up for KubeCon already, please sign up. You got the link in the chat. James is going to be there. I'm going to be there. We're going to have a wonderful time. It's going to be super cool. James, anything else we should know before we finish?
No, just, I suppose if you're at KubeCon in Valencia, then come past the Timescale booth and have a chat. I'm more than happy to talk about anything database or Timescale or observability or OpenTelemetry. Happy to have a heated discussion about whether SQL is the best language for OpenTelemetry. Really just want to talk to as many people as possible.
Good. We may have to organize a debate about that, the SQL on OpenTelemetry.
Yeah,
that could be cool. That could be cool.
Absolutely.
And last question, totally unrelated, but it came up in the chat while we were talking. Do you surf, James? I
do not.
That's okay. I was explaining the same thing, is that I'm from Northern California and I've never surfed in my life. That's okay. Not everybody from New Zealand has to surf. Not everybody from Northern California has to do it either.
No.
Yeah, I hear it's really hard. That's what everybody seems to tell me, that it's really hard.
So the main thing for me is not only is it hard, but like in Sydney, it seems like confronting. Like you go out there and there's lots of people that are really good at surfing and you're kind of like, as an amateur, just like basically throwing your board in their way. And those things are quite dangerous in the water. I don't really want to get
it's like your mission critical data just being thrown out there into the sea. No, I agree. And there can be, and that's what's funny too, is that surfers, the reputation being really, really chill, but locals only. This is my beach, my waves. That can get really, really nasty really quickly too. So be careful out there, folks, if you're going to surf somebody else's waves. Yeah. Okay. Do you, I guess I now have to follow this up. Do you practice any other sports?
I actually used to do fencing. I haven't done it in a few years, but yeah, I need to get that fencing one.
Okay. Next. Okay. We need to do like a Twitter Spaces or like a spin-off talk just about fencing and maybe how we can relate that to databases, OpenTelemetry, etc. That will be cool. Well, you heard it here first. You heard it here first, folks, because, and so how many years did you do fencing?
I started in high school and then maybe like 8-9 years. And then when I moved to Australia, I sort of bought some of the gear, but sort of dropped off a bit. But yeah, every so often I think, I should get back into it and then think, would I still fit in my fencing whites, which are Kevlar and it's very hot in Australia. So
yeah,
I would like to get back into it at some stage though.
I never thought of it. So fencing suits are made out of Kevlar.
Yeah, well, yeah, because you've got someone putting the whole weight on the little...
Just total stupidity of not thinking about that. So how much does a fencing suit weigh?
They're not super heavy. Like Kevlar's not the most heavy thing. It's not uncomfortably heavy. I mean, the masks are quite heavy. So having that on your head's a bit of a,
like you said,
bit of an issue.
The heat, yeah.
Well, yeah, I've never done it in Sydney. Like if you were fencing on a 40-degree day, you would die.
Sounds terrible. Yeah, that sounds rough.
I don't know how many Fahrenheit degrees that is, but that's
many. Don't worry, I've lost well into the 90s. I think closer to 100. So yeah, that's okay. So you have like a collection of swords in your house?
They're at my parents' house at the moment, but yeah, I do. And you've kind of got to tinker with them and put them together and fix the wiring on them. Yeah, it's a good time. I really like it.
Yeah. No, anyway, I would love to see it. Yeah, I would love to see a picture. I mean, I'm giving away free Timescale branding, but if you had a picture of, like a tiger with a sword, I think that's going to go quite well anywhere.
There we go.
Yeah. No, but that'd be cool. Anyway, so to be continued, we will learn more about fencing and its relationship with OpenTelemetry as well as databases. SQL is the best query language for a heated debate. James, thank you so much. We'll see you in Slack and we'll see you in Spain.
Cool. Thank you. See you there.